In this video, we're going to do some problems involving similarity, mostly similar triangles. Other than the first problem, this video will mostly be about proving triangles similar. Number 15, Sandy uses the shadow of a flagpole to estimate its height. When she stands 28 feet from the base of the flagpole, the tip of her shadow coincides with the tip of the flagpole's shadow, as shown. Sandy is 5 feet tall and her shadow is 7 feet long. How tall is the flagpole? So we are being asked to find this. So we have two overlapping triangles. I would recommend drawing the triangles separately. So I'm going to do that now. You got your small little triangle right here. Alright, so I'm just going to move that on over. And then you've got your larger triangle, which goes like this. Oh, I got that X in there by mistake. Let's see, can I change the color of this by doing that? No. Anyway, so here are the triangles drawn separately. Now let's label as many sides as we can. So looking at the small triangle, the bottom here is 7 feet and the vertical part is 5. And that's really all we know about the small triangle. And then the larger triangle, okay, we know that the vertical part is X. Now the horizontal part, is it 7 or is it 28? Ha! It's neither one. It's 7 plus 28. So that's going to be what? 35. So now we can do new over old equals new over old. I'm going to call this one new and I'm going to call this one old. So if I do new over old, that's going to be X over 5 is equal to 35 over 7. That's new over old equals new over old. And then I cross multiply. So looking at this diagonal, I have 7x. If I multiply it along this diagonal, well, what is 5 times 35 anyway? 5 times 35 is 175. So I have 7x is equal to, what was it? I already forgot. 175? Yep. Then I'm going to have to divide by 7 in a second, so I might as well do that now. 25. So when you divide by 7, we get x is equal to 25. So that is the height of the flagpole. 25 feet. For number 16, we are told that we can prove these triangles are similar. Which postulate would help us prove it? Well, we have the angles marked that they gave us, but in addition to that, we know that vertical angles are always congruent. So that gives us angle-angle. So angle-angle similarity would allow us to prove these triangles are similar. So now let's do the similarity statement. S corresponds to M. Alright, I can see that they are both blank. K corresponds to K. They are both double marked. And that leaves R corresponding with L, obviously. Okay, problem number 17. These triangles are not similar. Show, explain how you know. Use calculations and words. Well, the only way they are not similar is if the corresponding sides are not proportional. So I'm just going to go ahead and write that down because that has to be the case. Okay, now let's go back and see what in the world I'm talking about. So, in fact, first of all, what are the corresponding sides? Well, which is the biggest? 108. Which is the biggest here? 45. So those are corresponding. Which is the smallest? 64. Which is the smallest? 25. Those are corresponding. Okay, that leaves 84 and 35. So these are the corresponding. So the corresponding sides have to be proportional, and the way we would check that is by doing making a bunch of fractions. All right, each time make sure you build a fraction out of corresponding sides. So for example, maybe I would do 108 over 45, and I would see does that equal 64 over 25, and I would see does that equal 84 over 35. Okay, some of these reduce, some of them don't. I know 108 over 45 reduces somewhat, so let's reduce what we can. 108 over 45. Okay, so that's 12 over 5. Okay, I don't think this reduces. 64 over 25. Okay, 64 over 25. Nope. I don't think 84 over 35 reduces either. Oh, that is 12 over 5. Okay. Okay. So both of these simplify down to 12 over 5. However, they do not equal 64 over 25, which does not reduce. So this does not equal this, which does not equal that. Alright, so this shows that the corresponding sides are not proportional. We were close, alright, 2 out of 3, but we needed all 3. Looking at number 18, can we prove that these triangles are similar? We need to show and explain. We're going to use calculations and words. Of the 3 possibilities, I'm talking about angle, angle, similarity, side, angle, side, similarity, or side, 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 similarity. Only one of these has a chance of proving the triangles are similar, and that is side, angle, side, similarity. Alright, I have 2 sides and the included angle, and in the other picture I have the same thing. So I don't have enough angles for angle, angle, and I don't have enough sides for side, side, side. So I'm shooting for side, angle, side, similarity. Now, the included angle is obviously congruent because they're both marked 49. So all I really have to check is to make sure that the corresponding sides are proportional. So let's check that out. Between these two, what's the biggest? 98. What's the biggest over here? 14. So those should be corresponding, and that means that these would be corresponding. So if these are going to be proportional, that means that the fractions would be 98 over 14, and we're checking to see does that equal 84 over 12. Okay, let's take a look. So 98 over 14. Okay, that's 7. And 84 over 12. Seven again. Okay, so New over old does equal new over old. These calculations prove that the corresponding sides are proportional. And then here are the words that go with the calculations. Since we have two pairs of proportional sides and the included angles are congruent, the two triangles are similar by a side angle side similarity. Alright, can we prove that these rectangles are similar? Well, when it comes to any other shape other than triangles, based on what we know, if we want to prove them similar, we just have to use the definition of similarity. In other words, are the angles congruent and are the sides proportional? So both of these are rectangles, so automatically we know that the angles are congruent. They're all 90. So that just leaves, are the sides proportional? So let's decide which ones would be corresponding, just to be on the safe side. Between these two, 42 is the biggest. Okay, between these two, 35 is the biggest. So those would actually be corresponding. Alright, that means the 30 and the 36 are corresponding. So let's check to see if the sides are in fact proportional. Okay, so I would do, for example, 42 over 35. And I'm checking to see, does that equal 36 over 30? So 42 over 35. Okay, that's 6/5. And what about 36 over 30? Also 6/5. Alright, so the sides are proportional and the angles are congruent, so these two rectangles are similar. So there you go. These rectangles are similar because the corresponding angles are congruent and the sides are proportional. Okay, now let's talk about how you might prove that triangles are similar in a two-column proof. So pay attention to what we are given. We have angle Y is congruent to angle C. Alright, so obviously the reason for that is going to be given. So angle Y is congruent to angle C. Angle Z and B are right angles. That is also given. Alright, notice that we have not yet said that these are congruent. That's going to be its own statement. But let's go ahead and mark it. Z and B are right angles. So Z and B are right angles. But immediately after that, you should go ahead and say angle Z is congruent to angle B. And for the reason, you will say right angles are congruent. Right angles are congruent. Okay, and here we are at the end of the line, so it's time to say, guess what? Triangle XYZ is similar to triangle, let's see how X is blank? That corresponds with A. Let's see, Y. Y has a single mark, so does C. So I have AC, that leaves B. Now the reason is going to be angle, similarity. Remember, we only have three postulates or theorems that prove triangles are similar. We have angle, similarity. We have side, angle, side, similarity. And we have side, similarity. So we have two pairs of congruent angles, so that is angle, similarity. Alright, for number 21, they give us that ED is parallel to BC. So of course the reason there will be given. But we know that parallel lines lead to congruent angles, not congruent segments. So in this particular case, let's see, ED So we were given that ED is parallel to BC. Now this leads to congruent angles because if I make a Z like this, the corners of the Z are alternate interior angles. And if the lines are parallel, these will be congruent. So angle E is going to be congruent to angle C, and that is by the alternate interior angle theorem. All right. You know what? I'm going to write it out the long way just this once. For instructional purposes, alternate interior angle theorem. All right, what else you got? Angle EAD is congruent to what? Angle EAD, well, that is this angle and this angle. Those are vertical angles, my friend. So EAD is congruent to angle CAB. And those are vertical angles, so I'm just going to say vertical angle theorem. Or I guess I could say vertical angles are congruent. All right, or I could have said vertical angle theorem. Okay, looks like we're down to that final statement. Triangle ABC is similar to triangle what? Okay, ABC, so ADE. And this is going to be angle similarity postulate, because looking at the diagram as we've marked it, I see that we have two pairs of congruent angles. So number 22, we are given that angle A is congruent to angle CBD. So of course that's going to be given. Okay, so the measure of angle A is congruent to angle CBD. CBD. Bam. Then what else we have? The reflexive property. Well, I don't see any shared sides, which wouldn't help us anyway. But what we do have is a shared angle. Angle C up here at the top is common to the small triangle and the big triangle. So, I can say angle C is congruent to angle C. Right? It's congruent to itself. That's your reflexive property. And that's all we need, folks. Triangle ACE is going to be similar to triangle BCD. And once again, it will be angle similarity that gets it done. Alright, these last two problems are review problems from the previous unit, because we are now trying to show that these two triangles are congruent instead of merely similar. So please remember that we have 5 ways of proving that triangles are congruent. We had side, 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 angle, side, angle, side, angle, angle, side, and hypotenuse, leg. So look out for these. So for number 23, D and C are right angles. And of course, we know that right angles are congruent. And we also know we are given that AB bisects angle DBC. Angle DBC is this angle on the left. And the fact that it is being bisected means that it's being cut into 2 equal parts. So we have that. In addition to that, we have a shared side. So we can mark BA because BA is congruent to itself. It's being shared by both triangles. So which one of these 5 situations do we have? I see 2 angles and a side. So that means it's either going to be angle side angle or angle angle side. The question is the side between the two angles? And the answer is no. Here are the two angles. Right here where I just put that yellow mark, that mark would be between the angles. If we had that marked congruent, then it would be angle side angle, because the side would be between the two angles. But it is not. So because the congruent side that we have is not between the two angles, that means it must be angle angle side. Notice how the side is not between the two angles even when you write down the letters. So these are going to be congruent by angle angle side. Okay, now let's match it all up. Triangle ABC is congruent to triangle ABD. Okay, just keeping the corresponding parts in the same order. And finally, C is the midpoint of AE. So that means AC is congruent to CE. C is also the midpoint of BD. That means that BC is congruent to CD. And then, of course, we have our vertical angles. Alright, so this time I have two sides and the included angle. So that's going to be side angle side. Okay, so triangle ABC is congruent to triangle EDC. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.